All right. So, Steve, I want you to meet Jay and Phil. This is the quick intro before we get going. Of course,
Hey
hi,
guys,
Steve.
nice to meet
We've
you.
met at a few AIF meetings over the
Yeah,
years. So I'm part of a small but thriving analytics group here at the business school. Interestingly, I don't think any of us have business degrees. Am I right? Jay,
Well,
what is your
Phil,
degree in?
finance, huh?
I don't.
Engineering.
Engineering. Yeah, I don't know if I count your finance degree from Chicago as a business degree. We'll see, Bill. And then mine's in systems engineering from Virginia. So we all actually, so yeah, anyway. So we're not traditional business professors. We actually like to do a lot of data science.
Yeah.
Jay Tao's specialties are natural language processing. He also does quite a bit with video. Phil is a master of anything financial and sports. He's the editor of the Journal of Algorithmic Finance, and he's also the editor of the Journal of Sports Analytics. And he's also a well-known Wolfram Hackathon genius, right?
I'd
So
like
Steve,
to ask
why
you
don't
about
you
one of
explain
my.
who you are to the rest,
Sure,
and then
So
we'll get going here. Yeah.
sure. So I'm Steve Shwartz. I have a PhD in cognitive psychology from Johns Hopkins. Moved to Yale, moved up to New Haven to be a postdoc at Yale in the computer science labs with, you may have heard of Roger Schank, who was a well-known AI professor. And
Sure.
Roger and I started a couple of companies in the 1980s, and one of which went public, wasn't hugely successful. And then I started a pretty successful one in the 90s, but it was too late to be called an AI company. Commercially successful, but we didn't call it AI. And I was an investor and executive at Tango, which was a unicorn, and had an IPO in 2011, and started Device 42, which was won awards as the fastest growing technology company for many years in Connecticut, and recently retired from that.
Wow.
All right. So who wants to start with the questions?
I have like a million questions.
Yeah. See.
I'd love to hear what your thoughts are from like a robot psychology perspective.
So robot psychology, tell me what you mean by that.
Like, so psychology, you're studying how humans think and behave. Eventually, ideally, we'll have artificial general intelligence. Will the psychology of them be different than other people?
So I just wrote a whole book on why we won't have artificial general intelligence.
Ever.
You know, certainly not in our lifetimes. And you know, I just find it hard to believe that we'll ever have it, because I actually don't think we've made much, if any, progress since we were working on it in the early 80s. Not that we made much progress either, but
Yeah.
but I mean, I can give you my reasoning. So most of AI today has given us wonderful inventions. I mean, we're close to self-driving cars. Well, that's another topic. Machine translation. We can recognize photos as, you know, good and bad implications. But all of the amazing inventions are due to supervised learning, and in particular classification. A type of statistics that I used to teach at Towson University in 1978. Way more advanced now, uses neural networks, but basically the same idea. All of these inventions rely on learning how to take an input and classify it into one of a finite number of categories. And that's all it can do. That's all a supervised learning system can do. So if you have a supervised learning system, say, in a self-driving car that can recognize a pedestrian, that same system can't recognize a stop sign. It needs another machine learning system. Certainly can't translate language, and certainly can never learn to have a conversation or do anything truly intelligent. And I think you can make similar arguments for reinforcement learning and unsupervised learning is a bigger topic, but I think we've had systems that have come out like GPT-3, which do some amazing things, but in my view, show absolutely no evidence of learning anything real about the world or anything that could lead to thinking or reasoning capabilities.
Where does the next step go? So I agree with you, we haven't done it, and it doesn't seem like these approaches are fruitful. But is there proof that it can never happen? Or, I mean, one good insight, right? We haven't had it yet, but if we have one, could do it, right, or no?
That's an interesting question. And I think we're a little bit biased because of the rapid progress in machine learning. One really good insight got us to, in 2013, the computer vision program that all of a sudden was able to classify images. I'm blanking out on the name. A couple of good insights got us to machine learning, and machine learning happens very rapidly. I mean, it happens it can take forever, but it happens relatively rapidly. So I guess if there's one good insight that could lead us to a method of machine learning, maybe that could happen very quickly. The other perspective, which I kind of hold, is that machine learning is just learning patterns. And I just haven't seen any evidence that machine learning could learn general intelligence, could learn world knowledge, could learn to reason about the world knowledge. We really thought we were right around the corner in the late 70s, early 80s. Before we came along in the late 50s, people had the same thought and it didn't materialize. And by the end of the 1980s, people had pretty much given up on artificial general intelligence.
Yeah.
And I don't think people were really working on it at all until about 4 or 5 years ago. So now we have OpenAI, which is funded by billions of dollars to develop artificial general intelligence. They're the ones that came out with GPT-3. Google's DeepMind is working through reinforcement learning. So there are pockets now where people are working seriously on it. But people are working seriously on warp drive and time travel and
Yeah, so the thing that gets me in what you're saying here, Steve, is you're basically saying that since we can become very smart in very specific things, we have to become smart in a billion different specific things to even approximate human intelligence. So my question, what I wonder when I hear this kind of stuff is there any kind of digital, analog kind of split between the two? Right now, everything is basically digital. Can we come up with the AI equivalent of analog, where it learns approximate things and proximal things well, and is able to transfer it well enough that it's no longer needing to know a billion into specific things? It could start to learn a relatively few general things and fill in the gaps. Do you see what I'm saying?
Sure.
Until we make some real progress with that, and maybe it's already being made. I'm not the expert. Maybe Jay could tell us about that. I'm not sure that we'll ever get there.
Right. Yeah, and back in the 1980s, a lot of people thought fuzzy logic was the answer.
Yes.
That never got very far off the ground.
Oh.
And now, maybe it is, but nobody has any idea how to make it happen. I certainly don't.
I think part of the problem is that we're too married to math. With fuzzy logic, it was too close to regular logic and math in order for it to really apply. I mean, you're the cognitive psychologist. You know that we don't think in terms of math inside our heads when we have to do math, right?
Well, I stopped making that argument with my AA colleagues in the 1980s. That never flew, and it certainly wouldn't fly today.
Yeah.
You can't read an AI paper without a ton of advanced math.
Right.
So if we can focus on self-driving cars, because it's the same kind of question, right? Can computers generate new knowledge?
Mm-hmm.
And there seems like there's so many edge cases in driving that at some point you have to, when you see the person driving in front, most of the time it's fine, but sometimes you see based on how someone's coming out, you have to infer their intention. And do you think you can make it, that kind of stuff? Is that impossible or it's possible?
Yeah, no, I think it's a great question. I'm starting to write some blog posts on it because I think what's happening with self-driving cars is very frightening. There've been a lot of tests of self-driving cars. There may be 50, 60,000 self-driving cars out on the road being tested, but all with safety drivers, ready to, just like in my Tesla, I put it into self-driving mode, but I have to be ready to take over because a lot of times it'll go, into the wrong lane and, run me into a traffic pole if I'm not careful. But what's scary is that all of a sudden we're seeing states that are allowing self-driving cars without a safety driver. So California has just licensed Google's Waymo to put, half a dozen of them on the road. And there are a couple of other companies that have been licensed. You have states like Florida that pass a law that says, look, whenever you're ready, just put them out there. You don't have to prove anything to us. You don't have to pass any safety tests. I have a house in Florida. That scares me. So why do I find it so scary? And the answer is edge cases. Self-driving cars are made up of a bunch of supervised learning systems. So, like a Tesla has about, I think I heard Andre Karpathy, who's the head of AI at Tesla, say, they've got about 50 supervised learning systems. One to recognize pedestrians and one for stop signs,
right.
One for, lanes and, and on and on and on. And then they have, what's mostly conventional code to tie it all together with the smarts. What you do in this situation, what you do in that situation, which is all fine and well, but it means that you need code for every edge case, as Philip
right.
mentioned. So you have to be able to predict everything that you might run into. The problem with that is, we all have these. Almost anybody you'll meet can give you a one-off driving experience or multiple, and we use common sense when we drive all the time. We see somebody swerving, we say, hey, they might be drunk, I'm going to avoid them. If the temperature is low, we watch out for black ice. If a ball bounces in the road, we say, whoa, what if a child runs out to get the ball? If we hear an ice cream truck playing music, we slow down because there might be children in the area.
Mm-hmm.
Any one of these things can be programmed into a self-driving car. But what about everything? The manufacturer has to figure out every possible edge case. at least, to put out consumer cars like Tesla. And every edge case, there either has to be machine learning training data set, or you need hand coding. And if they don't anticipate something, what's going to happen? There was a self-driving car competition in Moscow a couple of years ago, and stopped at a light. There's a car stopped at a light. The car was stalled and couldn't move. So all the self-driving cars, one after another, just lined up and waited. And there was a 3-hour traffic jam.
That sounds like Russia.
Well, and I think, one of the things we're going to see is we're going to see self-driving cars put out, that drive very slowly, which in itself is going to cause congestion, and things like that are going to happen. And I think, they may set up self-driving cars so that they're ultra cautious, so they stop or go really slow if anything, they don't know what to do. But I think congestion is just as big a problem as accidents.
Highways should be fine, more or less, right? Highway driving?
Yeah, will they recognize the drunk driver?
No, they're not going to be perfect, but will they be better than humans driving?
Yeah, that's it's a good question, and there were other cases. For example, in a private corporate park, you just have a shuttle that goes back and forth between two places. It's fully mapped. It's going at 8 miles an hour. What harm can it? How much harm can it do? And Waymo's testing these self-driving cars in a 50 square mile area of Phoenix, where every bump in the road is mapped.
Right.
And I'm sure they send out drivers every day to make sure nothing's changed. And if a car sees something that's changed, they get it into the map right away. So that's going to reduce a lot of edge cases, but there's still going to be edge cases, and what's going to happen when a self-driving car without a driver, runs over that mother pushing a stroller because, in the case where the Uber car ran over a pedestrian, that first it thought it was a piece of paper, and then it thought it was something else, and then when it finally realized it was a pedestrian, too late.
Right. I actually have a friend, Brian Smith, who's been working in intelligent highway vehicle systems since the 80s. And I used to kid him about working on smart cars. And he said, no, actually, look at the name. We work on intelligent highways. We assume the cars are stupid. Right? Jay, I assume you might have some reaction to this. I mean, you've been thinking about this a long time. What do you think?
I think, this is a great point, that we are at a point we need a big breakthrough. The last big breakthrough we had in the field of machine learning, or more specifically deep learning, was 2013, when Yann LeCun had backpropagation.
Right.
We are deemed for a big breakthrough. Well, the problem with that, and I'm agreeing with Steve here, is basically we don't have the computing power for the breakthrough. So hear me out. A lot of people will think I'm crazy when I'm saying we don't have enough computing power, but I'm not. We have more than enough computing power for the status quo. But the status quo is so low, it doesn't count for anything. What does that mean, right? So a lot of people say, we have all these fancy AI toys that, can do all these wonderful things. And I myself are using them every day. But the whole thing is built on a randomized model. How do we initialize weights in those neural nets? Random. everything is random.
Hmm.
But the randomized model, the randomized initialization is actually very inefficient. For example, we should be able to put in some prior knowledge onto those weights, as those weights onto those neurons. So you don't have to start from random. You can start from something.
You want to warm start it.
Exactly.
Yeah.
So one of the things people are suggesting is basically Bayesian-based neural net, where they are using Bayesian model to give the neural net a warm start.
Wow.
When we move to even something like Bayesian, we all know Bayesian is a so simple model, but the problem is we don't have the computing power to initialize a neural net have more than 50,000 neurons.
Right.
Even whatever the quantum computer, whatever computer we have, we cannot handle that. So that's what I mean by we don't have enough computing power to actually move to the next stage. And I think that alone, we're gonna build artificial general intelligence or something. If we want to move this to the next level, if we want more accurate or at least self-learning intelligence, we do need the next breakthrough, and we are deemed for that. We just need more computing power. So can we reduce the circuit from say 5 nanometer to 1? Can we do that in the next 10 years? I don't know. If we can, maybe we'll have the next breakthrough. Now the part is not on the method. We have a lot of method, For example, we can move from the random to anything. Anything is better than random.
Right.
But we just don't have the tool to support that.
Interesting. Phil actually does some work with, this is going to sound weird, the theory of everything and computational models of this with, I saw a paper, Steve Wolfram, we were talking about recently about this. And my impression of it was basically everything is actually quantized, and the idea that things are at all continuous is kind of just us filling in the gaps. Is it possible that we might reach a point where if we have enough probes, we can't tell the difference between something that is, a billion different little machine learning algorithms versus, one master intelligence? Is it possible that we might reach that? So Jay Tao is arguing that if we have more computing power, then the models can become more detailed and we can have more of them. Basically, that's, what he's saying. You have the weights and whatnot. And if you can warm start everything, you're basically able to get those weights closer to where they need to be quicker, and you can have more of them. Am I getting this right, basically, Jay?
Mm-hmm.
Okay. Mm-hmm. So at what point do we get to where, people can't tell the difference anymore, that it can do it as well as we can? How far off into the future? Now we're into, I hate to say it, some sort of a forecasting thing. I don't know as to when that might happen. It's a fascinating question.
Yeah. I mean, first of all, if you have say you have 175 billion supervised learning algorithms, okay, don't you still need a controller that decides when you use which one? And that's the real intelligence. You still need common sense,
right, to
be able to do that. So having 175 billion of them, I'm not sure solves the problem. I'd also point out that we've had a little experiment in scaling, through OpenAI's GPT, GPT-2, and GPT-3 systems. So I think GPT-2, and I might get the numbers wrong, had about 1 billion neurons or parameters. GPT-2 had about 15 billion, and GPT-3 had 175 billion.
Right.
And clearly, what each system could do, the more neurons you had, the more fantastic things it could do. But you would think that going from 1 to 15 to 175 billion, you'd have seen some evidence of these systems. They're reading practically everything on the internet. If they're going to acquire knowledge, wouldn't they at least start to acquire knowledge with 175 billion neurons? But if you look at the fake news that they generate,
Yeah.
all the facts are wrong. So why is that? Or, to me, that supports the argument that says all they're doing is learning word sequences and memorizing word sequences and memorizing word patterns and, learning things like the equivalent of word embeddings and, putting words in a large n-dimensional space. But they're not really learning any knowledge.
So you're saying it's more like mimicry rather than learning.
Yeah, like a parrot.
Interesting.
A transformer.
Yeah. Go on, Jay.
Any transformer-based model has limitations. A model like GPT-2 is using the decoder part of a transformer, where the encoding part is totally ignored. Compared to Google's BERT or Microsoft's XLNet, where they're using the encoding part. So in other words, one is like a word embedding model. The other one is like a generator. So they all have their limitations. If you just use the encoder part, you don't know what you're encoding for. So that's why in BERT and XLNet, at the very last layer, you have a fake classifier to control what you're encoding for. So that's why BERT has different submodels. And then on the other hand, GPT-2 or even GPT-3, they are a generator. So you need to control the generator so it doesn't really go wild.
Right.
So that's why something like reinforcement learning or something as simple as generative adversarial networks may help here, because if you use GPT-2 or any generator as the generator model in GAN, you need a discriminator, you need a policeman there saying, no, you're fake, go out, right? So I think that's the key here. And of course, a lot of crazy scientists are saying, why can't we use the encoder and the decoder part together? Well, that defeats the purpose of transformer. The whole idea of transformer is a theoretical framework where you have different functionalities. So far, we haven't seen any use case that you need the encoder and decoder part together. We may, in the near future, again, we don't have enough computing power.
Would you say that there is any domain that has actually been solved with AI?
I think depending on how do you mean by solved?
Where it can
Right?
perform at an expert level without making mistakes that a human would never make.
Okay, so I think I can think of one example right now. The deepfake.
Okay.
Or any similar generative system. Okay, so I think the deepfake. Maybe I'm not very sensitive or knowledgeable about human photos.
Right.
Photos of humans.
Right.
I saw those photos. I think they're taken by or taken off human, not generated by machine.
Right.
Right. So I think that's the main thing. That's the main thing I can think of right now. Is basically in specific area, and I'm gonna quote you here, Chris. You told me back in the day that the holy grail is to build artificial general intelligence.
That's right.
And recently, we give up. We
Yeah.
don't want to build artificial general intelligence anymore. We want to, and I'm going to use exactly your words. We are building smart animals.
Yeah.
We're using smart animals so they can read better than us. They can look better than us. They can run better than us.
Mhm.
There's no point of general intelligence anymore. If they can do one of these things better than us, they are some kind of AI. So we're building specific tools, not something to replace us. And as I usually joke with my grad students, I would worry about artificial general intelligence as long as I see one of them wake up in my bed and wearing my pajamas.
I think it's been 20 years since Bill Joy came out with his "The Future Doesn't Need Us" article in Wired. Have you guys ever read that?
I vaguely remember it.
Remember that?
Remind me.
So for those who don't know, Bill Joy was one of the founders of Sun Microsystems. He wrote most of the guts of the
Java.
BSD Unix distribution at Berkeley when he was a grad student. He was also one of the 3 guys that invented Java. So he's been around a bunch, and he basically started becoming, he basically retired to his place in Vail in the late 90s. And people kept asking him, well, why are you doing this? And, you know, he was already a billionaire. I guess he could do whatever the heck he wanted to do. But he started making these statements about, well, the world is just getting too crazy. And this Wired article was sort of his long form version of this. He was saying that, you know, the technology is going to start to take over. You know, now this isn't quite the Terminator here, you know, and he was saying that as we start using sort of this narrow AI to do more and more functions, eventually you put them all together and they are sort of a generalized AI. It's just that it's in lots of little pieces, and that human expertise won't be necessary anymore. So, you know, he didn't like that future. He'd rather be out skiing, right? It's funny, it's 20 years ago now, and it hasn't quite happened yet, but it is getting closer. I certainly get a lot of robocalls where it's not necessarily easy to tell that I'm talking to a machine.
Yep.
Right?
Yep. No, I remember having a conversation and saying, look, I'm going to ask you, are you a robot or not?
Right.
Because I you know, I really couldn't tell, because, you know, but yeah. Has anybody seen The Social Dilemma yet?
No.
It just hit Netflix.
Okay. I'll put it on my queue.
And it's a very compelling documentary about how technology and in the background AI technology is taking over and causing divisiveness by you know, figuring out more and more exactly what we like. So, you know, they finding the extremists in us and feeding it to us. And yeah, it's an interesting documentary. I'm going to write a blog post about it. I'm not sure I completely agreed with it, but I think, you know, divisiveness in our society is coming from other places besides technology. But it's very interesting.
How come we never hear about technology bringing people together anymore?
Yeah.
Is there a way it can, or is it guaranteed to just bring us apart? What do you think?
I don't know. That's a good question. All anybody seems to do these days is complain about the big tech companies trying to take over society. You know, whereas it seems to me that right now we're using technology, like in this session right now, in order to be able to do things that we couldn't have done, you know, so many years ago. I remember teleconferencing technology back in the 80s. It was not good, right? Anyway, but so I think that one of the things that, so I used to teach a class in technology and society years ago. And one of the things we had in there was that technology is inherently neutral, but it's sort of chaotic neutral from if you do Dungeons and Dragons or whatever, and that it needs to be used in order for it to have any effect, and how you use it is what matters, right? And it's that us humans, I think, need to figure out that we're going to use technology to bring us together instead of to divide us and yada, yada. I really do think it's on us.
Yeah.
What do you think,
Yeah.
Steve?
You know, it's an interesting question. I until I saw the social dilemma and, you know, some of the more recent, hearing some of the more recent concerns, I'd always thought of tools like Facebook as bringing us together.
Mm-hmm.
You know, I always said, gee, I wish we had Facebook from when I was in college, in high school, and college, and graduate school, and you know, and from Yale. I'd love to be in touch with all those people still. Yeah, so I think there's both sides, but I think it does bring us together somewhat. And I think, you know, tools like Twitter, all these tools bring the world a lot closer together. So I think there's both sides to it.
It could also just be that it brings people together and they don't like each other.
Right. Right. Yeah. The argument of the social dilemma is that it you know, pushes you into extremist groups.
Yeah.
Because it's going to figure out what you like and what you don't like, and
Right.
I guess everybody must have some extremist views.
So, Steve, I'm going to take you in a very different direction. Tell us what Device 42 does.
So we started Device 42 to solve a very pragmatic problem that I had as a chief technology officer at various companies, which was we didn't really understand our own infrastructure.
Mm-hmm.
You know, it's just to take a simple example. When I was a CTO of a big global financial services company, and we'd have an outage in one of the regions, I'd have to get everybody who knew anything about it on a conference call, and nobody could get off the conference call until we figured it out. And
Yeah.
I'd always, every single time, I'd ask questions. Well, what's running on the machines? What machines are affected? What's running on the machines that are affected? And everybody would say, well, you know, we'd have to shut everything down and do an inventory, and it would take us a week to answer those questions. And they would always be the most frustrating thing in the world.
Right.
So we set out to build a system that would be able to answer all those questions, and then to be able to take all that data and perform analytics and AI on it.
Mm-hmm.
And we were very successful with the first part, and the second part is just coming. And the reason the second part hasn't come is because back in 2012 when we started, we put the system up and we asked people to put all that information about all their critical, everything about their infrastructure in the cloud. And it was like, nope, give me a piece of software I can run behind my firewall that nobody can ever find.
Yeah.
So we pivoted, and that's what we did. Today, though, people are willing to put all that information in the cloud, and we're just starting. And I've retired. I'm just on the board, but you know, we're planning a project to start doing analytics and AI based on the data that now we're finally accumulating in the cloud.
Interesting. So is the goal to, you know, improve uptime? Is it to eliminate breaches? What kinds of things do you think you're going to target when you do the analytics with these systems?
So there were all kinds of questions as a CTO or CIO that you know, people don't really have good answers to. You know, what kind of equipment breaks the least? What has the best uptime? What's good for AI? What, you know, There's just a whole rash of questions that you'd love to know what your peers are doing and,
Right.
and how they're doing it and how they're thinking about it. So it's a pretty wide range of questions.
Interesting.
Yeah.
All right, Phil, you got anything for us?
Yeah, I'd love to hear your thoughts, Steve, on how you've seen AI and NLP progressing and your forecast or prophecy. Where do you think it's going next?
So I think we're going to see ML and NLP get better and better. You know, we're seeing on the ML side huge improvements in algorithms. You know, instead of requiring 170 billion, 5 billion parameters, you know, there's some systems that have recently been released that can get the same results with, you know, a small fraction of the neurons. We're seeing democratization where you can, you know, when I wrote ML algorithms 5 years ago, you pretty much had to know TensorFlow, you know, and before that you had to write the code yourself, and then came Keras, which anybody could use pretty much, and then AutoML, which will pick the algorithms and the hyperparameters for you. And now you can go on to, I remember having a laptop with a GPU and running really a small ML algorithm that just ran for days, and very frustrating. And then all of a sudden I could go on Amazon and rent a gigantic machine that would run that same thing in seconds and cost pennies.
Right.
So, you know, we're seeing democratization. We're seeing, you know, getting back to an earlier topic, we're seeing better ways of initializing weights. So both in vision and natural language processing, we're finding ways of taking what we learn from one system, essentially transfer learning, and using it to initialize the weights of other systems. Multitask learning, you know, in a Tesla, you may have 50 independent systems, but they all have the same set of initial layers are all shared. So you get advances like that. But I don't see how we're going to get to that next level, as I said before. And in NLP, it'll be interesting to see how much of an impact machine learning has. I mean, certainly GPT-3-like tools can do some very impressive things, and will continue. There's a lot of work on trying to get NLP systems to learn common sense. You know, there are massive numbers of data sets where if a system can learn to answer questions from the data set, it must be using common sense. But then when you dig into it, you realize that there are all these artifacts that, you know, are amenable to word-based strategies. So, yeah. So, you know, a lot of improvement, but I don't see a massive jump. But I'd say that I didn't predict AlexNet in 2013 or any of the other major breakthroughs. I was very surprised by, you know, when Google's machine learning-based natural language machine translation system replaced their phrase-based system and was, you know, an order of magnitude better.
Right.
Yes.
Awesome.
All right.
Can I ask you, behind you, it looks like you won a tournament, or what is that plaque?
Yeah, it's the one big golf tournament I ever won.
Hey, that's awesome.
It was about 10 years ago. You know, I have all kinds of other awards from, you know, companies and whatever, but the golf tournament's the one that's on the wall.
That's awesome. That's really great.
All right. Are we done? What do you think? Any other questions?
I think that was wonderful. Steve, thank
Yeah.
you so much for your time.
Oh, nice
Yeah.
meeting all of you.
Nice meeting you too.
Finally, good to see you again, Chris.
When does your book come out?
February. It's going to come out February 6th.
Oh, great.
Very good.
Awesome.
Yeah.
Awesome. We're looking forward to it. Thank you so
Oh,
much.
good. Yeah. Great meeting you guys.
Great meeting
All
you.
right.
Tim.
All right.
See you,
Thank you.
Steve.